but I'll crack on. So yeah, hello everyone. Many thanks for joining us this morning. Got a good session lined up today, something slightly different, and we're going to be hearing from an end consumer instead. Hopefully our chat will be of interest and use to the professionals in the room, hearing how a homeowner actually goes about researching, planning and selecting his preferred choice. So we have Julian Clark with us today. He is a sustainable homeowner, as he was just telling me. He was just slapping me on my wrist for not doing enough in my property. So yeah, Julian is a sustainable homeowner with a solar PV array, and believe you drive a couple of electric cars. He'll explain why he installed an air source heat pump to replace his boiler, his oil boiler, why he selected the installer that he did, and the unit, and the challenge. And we'll talk about the challenges that he faced in doing all of his research as well. Sorry, I'm just trying to make sure everyone's admitted. Firstly, though, just like to cover off some admin. Just change the screen. As it says here, please leave your microphones on mute throughout the presentation. Well, it's not a presentation, it's going to be more of a very informal chat between Julian and I, but we would like some input from you guys. We always want you to be involved as well. The chat is enabled, so please ask any questions through the chat box. I'll either ask you to raise your hand or pose any question in the chat box, and you can either come off mute. So Julian and I will get started, but please, we want you guys to be involved as much as possible. It's quite nice if you could put your video on just to give us a feel that we're talking to someone, but I sometimes appreciate that not everyone wants to do that, but it does actually benefit us if you could do that, so that's much appreciated. This webinar is being recorded as usual, and we will upload it onto Mesh Energy's YouTube channel and also to Mesh as well. I do know that some of you on the call are new to MESHWORK. So just a quick slide here on who we are, what we do. So MESHWORK is your low energy and sustainable building design community. We're looking to push towards a carbon neutral world by building better houses, and we want as many people as possible to join us in that quest. If you do see value in attending webinars like this that we host, and from the chat and the articles on the network, then please make as many referrals as you like, because it just allows us to invite more people, get more people involved in the conversation, and ultimately it benefits everyone. MESHWORK was actually founded by a company called MESS Energy. They are independent, or we are independent energy consultants, and our mission is to instill confidence and pride in low energy projects through intelligent design, as it says here. But ultimately, MESHWORK stands alone as a separate business, and it's a free to use community. So yeah, please get involved. Before we get started, as usual, we'd just like you all to introduce yourself via the chat, say who you are, what you do, why you're here. Again, as I said, anytime throughout the chat, please ask any questions through the chat box, or leave them to the end if we have time. But I know Julian is well, as I said, he's the end user, but he's very diligent, very knowledgeable. So it's good to hear from someone who it's gone through the whole process. So Julian, thanks for joining us.
Simon, thanks for the introduction. I don't know whether I necessarily count myself as an expert or anything like that. And with the initials JC, I do hope that this isn't going to be preaching too much. I do get a bit evangelical about it, but appreciate everybody's time, and thanks for joining to listen to me witter on.
No, it'll be good. So in order to get started, it might be quite useful if you just set the scene, sort of explain the type of property you live in, what was your energy usage did you take any measures to reduce your energy usage before installing the heat pump, and the actual trigger, why did you consider installing an air source heat pump?
You might have to prompt me a couple of things there. There was a long list.
Yes.
So we live in we bought a new property in 2002. It's a bungalow in rural Worcestershire. about just over 200 square meters, 204 square meters. It's designed to look like a glass house. If you want to allow me to share,
Yeah, I'll stop sharing my
I can do a
screen.
photo. I can do a photograph of the place.
Mhm.
Let me share my screen. That one. So we live in a walled garden by a big property, and the properties are supposed to look like glass houses because originally there would have been glass houses that fed the big house. So we had quite a lot of solar gain. We were heated with an oil boiler because we're quite rural Worcestershire, so we didn't make the gas main. But over the time, we've gradually improved the fabric and infrastructure of the property. Just a bit of a list here. In 2012, we were lucky enough to get in with the feed-in tariff to get the solar panels. You can see there above the garage and the kitchen.
Mhm.
We have 4 kilowatts of solar. So before that, we were using something like 5,500 kilowatt hours of electric per year. With a bit of nagging by me to my daughter and my wife, we got that down to about 4,500 kilowatt hours of switching stuff off and things like that.
Yeah.
And when we had the solar panels fitted, we got that down to 2,700 kilowatt hours per year of use.
Hmm.
So that was 2012. 2013, we had a Solic 200 electric diverter fitted. So that takes spare electricity generated by the solar PV and dynamically then diverts it to the immersion heater in the then it was just a hot water tank. And if you switch the kettle on, it switches off the heat in the hot water, sorry, the cylinder. And when your kettle's boiled or whatever you've been doing is boiled, it then switches back on again. So
Okay.
we over the summer since 2013, we've been able to, switch off the heating source, and all hot water is generated for free. I would recommend that product. It's British made, very well engineered, 10-year warranty, very easy to fit. It doesn't have the you might have come across Emerson or there's products from My Energy that do things very similar.
Mhm.
But it doesn't provide data, but it's a really good product. Very well made. In 2014, we doubled the insulation in the loft. They put in 150 mil, and we increased that as a bungalow to obviously a big floor area to 300 mil in the loft, and saw benefits there. In 2015, because of all the glass, if that's an ordinary window frame, we've got something like 72 of those around the property. So quite a lot of heat loss through the windows. We triple glazed the property, and again, seen benefit there. We had you can see the roof glazing as well, and the metal roof that got replaced under NHBC warranty after a failure in 2016, and that's much more man for the job, if you like. It's a much stronger roof, and it's got a much better insulation in it as well. I've also then potted in the background to reduce leakage and things like that. So I don't know whether we've got bathrooms which have extractor fans that previously were those Manrose ones that just, if it's blowy outside, it's blowy inside.
Yeah.
I remember sitting on the toilet and bloody hell, it's cold in here, and it's just a draft coming out. Well, there's a product from a company called Icon that has a rose cover over it, and then when you switch the fan on, the rose opens up and it just stops the fan draft there, for instance. So we replaced those. I've put covers over the excursions, I think they're called, over the locks on the back door to stop the draft through then. Just little things to reduce drafts. And then last but not least, we had a new front door, Palladio front door, just before Christmas last year, but that actually happened after after we had the air source heat pump fitted.
Right. Okay. So there's a lot going on there.
Yeah, and it's just, but people have, it's just ongoing maintenance really of the property, and I just tried to get the best that we could afford to improve the fabric and insulation in the property during the times that when we would get replacing stuff. It's a bit like when the cooker fails. Well, let's get a cooker that's a low energy cooker
Sure.
and just try and get the most energy efficient things to try and reduce your carbon footprint. And this is where I'll get back to me preaching. Let's not go there for now.
But that's what drives you then, is it? Because not all of these changes were made just because something was broken. It was because you were doing your utmost to make these positive changes.
A little. My wife is an ex-accountant,
Right.
so I have to cost justify everything. And things like the triple glazing, it was probably about 4 or 5 grand more than the equivalent double glazing. We probably would never get that back on a per pound basis. We were justifying it based because before we had wooden windows, and every 3 or 4 years we were having to spend 2 or 3 grand having them painted.
Yeah.
I'm a get a man in type of guy, not a DIY kind of guy. So and there was also going to be a heat loss reduction. So you can start to justify the investment, but it's still a bit bit esoteric. So I'm trying to do the right thing, but equally having some eye on the budget as well.
Yeah. And then some of these, well, before we come on to the heat pump, but not everyone, I don't want to sort of make any assumptions, but I'm assuming not everyone will be able to undertake all of the works that you've been able to do. But equally, some of these things, no doubt, weren't that expensive to do. So loft insulation, 200 quid. Yeah.
Doubling the loft insulation. It's going to have less impact on a 3-story house than it is on a bungalow.
Sure.
But that there's a lot of 200 square meters of loft insulation. It was no cost at all, and it's a no-brainer really.
Yeah.
We did have the debate about as I mentioned, the double to triple glazing. We've got a U center value of 0.7. So if we'd have gone with a good double glaze, it would have been about 1.1, I think. So it's just there's a benefit there.
Sure.
But that was a little bit difficult to justify. Another example, we had the new front door, but I went round, and in fact, front doors are not very energy efficient. You have to work hard to find one that's got a good U value, and actually the Palladio one is one of the better ones. You'd have to go to a Swedish or a Norwegian one, which are then going to be ridiculous amounts of money to get a better U value. But if you go to your typical door manufacturers, then they're still at 1.5 U values of 1.5, which is so. It's just an eye on the. For me, it's just an eye on the as you come into replacing. So that was a 20. There was a bit of a draft under the old door and stuff like this. It never fitted properly, despite the fact we'd had a second new one when we bought the property new. Yeah. It's just keep an eye on the fact of thinking when you're replacing stuff, then because things wear out, things break. Buy the best that you can afford, the lowest, but most energy efficient version of whatever it is.
No, that makes. But
I recognise that I am lucky to be able to have done that. But everybody has to maintain their property, and when you maintain it, do the best that you can.
Do the right thing. No, absolutely. No. I mean, it's a good rule to live by. Julian's just asking us to share any names of any products that you've used, but we perhaps after this I'll ask you to email them to me, and we can share them on the post when I put this back up onto.
Yeah, I've got a short presentation at the end which I can go through, and I've just listed some web links in there.
Cool. Okay. And then coming on to the air source heat pump, what was the trigger then?
So I think I saw an advert in about 3 years ago from EDF, and EDF were offering what they called a hybrid system. So I got in touch with them, and they did an assessment. Sorry, they did the let me just share this. Can you see that? So this is my efficiency rating. So they did a EPC. They did a.
Well, it's not come up, Julian, yet.
Oh dear. Sorry. Let me have another go at that. Why do I not see that? Let me keep talking, and I'll. I can't actually find out where I can't stop sharing. Oh, that's why. We have to stop sharing and then reshare. this is where Teams is so much better than Zoom,
Right.
because you can just move things in and out. Can you see
Yeah.
that now?
Yes, we can. Yes. Yeah.
So yeah, they came back with a design. So they did I got a free EPC actually out of it, but they came back with a design that said you will keep your oil boiler. Sorry, we did have a new oil boiler in about 8 years ago, 7 or 8 years ago. So we originally had an old, I've forgotten the make of it. We replaced it with a Worcester Bosch oil boiler, one of the green slave ones, I think they're called.
Green Star.
Green Star, thank you. And they said you keep the oil boiler, but we'll put an 8 kilowatt air source heat pump in, and they estimated that 80% of the time that the air source heat pump would be running. And then they put a complicated control system over it, and it then would switch over. It got really cold, so the oil boiler would run. And I'm like, my background is as a systems engineer. I'm an IT consultant, and it's like that seems very complicated. I've still got to maintain, servicing the boiler, and I've still got a 2,500 litre oil tank out the back. Can you not replace the whole thing? Oh no, we don't offer that, sir. Okay, and that's what triggered me to then start looking around at why can I not get a bigger air source heat pump to then replace the whole thing? And another bit of information, I've married, coming up to 26 years of marriage. At the time I was 24 and I was heading towards 25. And I was jokingly saying to people, well, my wife had said, we're not taking out radiators and we're not replacing pipework. That's the design constraint. And the numbers of people that came, we have big pipes that run in the loft in our bungalow, and they're either 32 or 28 mil, but we have 10 millimeter microbore pipes that drop down to each of the radiators. And we do have a lot of radiators in the property because of the double height rooms in the sitting room, in the dining room, where you saw the glass roof and stuff like that. And the numbers of people that either, this was during COVID, so I was having to walk arounds with my iPhone and videoing, and the numbers of people say, oh no, we can't do that without replacing the microbore piping. And I was jokingly saying, well, my wife Jackie's going to build a gibbet on the driveway, and I'll be just hanging there, and I won't make my 25th wedding anniversary because you cannot dig up the. We could put, another one was, we'll dig up the floors and we'll put underfloor heating in.
Yeah.
What? Don't be ridiculous. So that threw out, and I ended up going to probably 12, maybe more people, and 4 or 5 of those probably thrown out because of this. Oh, we've got to replace the microbore, so that's a non-starter. But I ended up getting about 6, 7 quotes from various installers who then talked about a range of different heat pumps. In the background, I was doing research, and if you buy a car, you buy a refrigerator, you buy almost anything, you can get a YouTube video on it, you can read what car, you can get comparisons between different systems.
Yeah.
And from an air source heat pump, there was nothing. And it was going to be the 3rd most expensive thing that we bought besides the house and a car. And it's just like, well, if I'm buying a 400 quid refrigerator, I can compare the Bosch one to the, I don't know, the Indesit one to whatever, but I can't with a 10, 13 grand air source heat pump. It's ridiculous. And I still couldn't find that. I've never been able to find that. There's not a my airsourceheatpump.com that does comparisons between them.
No.
All I was doing was asking dumb questions, and I'm quite good at doing that. Of the engineers who'd come. So an engineer would come in with a design, and I'd question about it, and then the next one would come in. You then got more information to then compare that solution to, and we ended up with a logical place of where to put the heat pump, and I can go through pictures of that. A logical place of just replacing the hot water tank. We did have a hot water tank. We needed a new one. And a discussion about whether there needed to be a buffer tank between the two, between the air source heat pump and the hot water system, or whether it was a direct connection. And then you've got the debate of a Daikin versus a Mitsubishi versus a Samsung versus a LG versus a NIBA or Stiebel Eltron, and
presumably you when you said you speak to the installers, you don't, an end user doesn't pick up the phone and contact the actual manufacturer. Then it's all done through the third parties.
So yes, I'm not talking directly to the manufacturer.
No.
But the key, I think the key difference is to get a heating engineer versus a gal or a bloke who are just boiler fitters.
Yeah. Okay.
So I ended up with a list of about 3 or 4. They all happen to be gents, but men who I built a trust up with, that thought I realized that they understood heating systems and how to design an air source heat pump to meet my requirement and give me some confidence.
Yeah.
And then you've got a conversation about, well, what's the difference between a Stiebel Eltron and a Daikin and a Mitsubishi?
Mm-hmm.
And that came down to a number of factors. The Stiebel Eltron and the NIBA for the equivalent system was about $2,000 more. And you're comparing the specifications of the systems line by line almost, and I couldn't see any difference between those two products and a Daikin or a Mitsubishi or whatever the other. But you talk to the people, oh, these are the Rolls Royce of the products. Well, why are they? What makes them the Rolls? Well, they're better. Well, how are they better? And they couldn't get what better actually meant.
Yeah, because they get a better margin.
Could be. Oh, yeah. Well, I couldn't. If you compare the one of the measures is a coefficient of performance, and then you have a seasonal coefficient of performance. So that's the key. So some of these are designed for very, very cold climates, and they might perform better in Sweden or whatever. Fine, I don't live in Sweden. I live in rural Worcestershire.
Yeah.
So I need something that fits there. So I ended up with a list of. I crossed off NIBA and Stiebel Eltron. I couldn't justify the $2,000 more. I couldn't find anything that made it better.
No.
So I ended up with a list of 4 of Daikin, Mitsubishi Ecodan, Samsung, and LG. And I then narrowed that down to Mitsubishi and Daikin. Mitsubishi are actually made in Scotland. So you've got to think of, coming from my IT industry, you've got to design the thing to start off with, but then it's the thing
Service.
I think differentiates us from our competition is we design for a long-term service life.
Yeah.
So it's got to be something that's supportable, and I want this thing to last 10 and plus years.
Yeah.
So having them manufactured in the UK means that the parts are going to be available. Oh, brilliant. But they only had a 7-year warranty. I say only a 7-year warranty on the Mitsubishi. Daikin have a similar 7-year warranty, but they do a 10-year fixed price service contract. And that was the thing that ended up pushing me towards Daikin, because I like the idea of just paying, and it works out about £180 a year I pay as a service contract. But that means they come out and service the the product, and any spare parts, it's included, and they will fit those spare parts for 10 years. And it's fixed at £180 now, and in 2032. And that to me spoke volumes, because I have to have the thing serviced. And if you have a gas boiler or an oil boiler, you have to have it serviced annually to keep it optimum.
Yeah.
So I needed the same. So that's the reason I ended up going with Daikin. And the company I ended up having it fitted, who were based out of Warminster, a company called EcoBubble. The proprietor there, Martin, I think he's been in the heating industry for a long time, and he just gave me confidence in his ability to meet my requirements and the design of the solution that he came up with. And he then did it to meet. I'm pointing at the screen because you can't see it, but the thing I'm sharing on the screen is, if I just go down the page a second, the demand. If I go to the bottom here. No, not that one. There's the actual heat demand that's required in the EPC, which it's the number that gets is bandied about, but it's whether it's a real number. We'll come back to that one. Where are we? I can't find it. Oh, here we go. So they in this it talks about nearly 21,000 kilowatt hours of space heating and hot water heating of about 3,100. You can see that.
Yeah.
So that's quite a big number.
Mm-hmm.
We were using about 1,500 litres of oil per year. And that was doing all our space heating and a little bit of hot water, but mostly, as I explained, it was via the solar PV.
Right.
So they end up there, and quite a few people came in and actually it was done via video, and I sent a lot of data out. I measured the rooms and worked out the area of the radiators and the areas of the windows and stuff like that. So the heating engineer needs to do a heat demand calculation and a heat loss calculation per room for your property to work out what's the correct solution for you.
Okay. And
go on, keep going. I'm
and
going to stop sharing this.
These installers, like the number that you ended up speaking to initially, are they agnostic, or do they have are they affiliated to a particular manufacturer? And how long did that whole process take? Because the thing here is, more often than not, a trigger might be the boiler just breaks down, but normally you would want a new boiler pretty quickly, especially when they normally break down in the winter. So I mean, to switch over, you've really got to be to persuade.
So yes,
a layman, you've got to be pretty dedicated to the cause, or have you not?
Yes, 7 or 8 years ago, when our oil boiler failed, it's a pressure sale to get a replacement. Especially, it took me 2 weeks to get a new boiler replacement in, and my wife was then complaining about how. And it always happens in the winter, doesn't it? It never happens at July the 7th.
Yeah.
So yes, you can't. Can't's a strong word. I doubt you could design and fit an air source heat pump when your oil boiler or your gas boiler has failed. It can only be done when you're thinking about replacing them at some point, not at the bloody hell, the thing's not working.
Yeah.
Because there's a lot of design work that needs to be undertaken. But in the example we were talking about, Simon, before, you were saying you're doing a lot of work in your house. That would be a good opportunity.
Sure.
To make the changes at that point.
Mm-hmm.
Yes, it probably took, because I wasn't exactly right. The work with EDF. EDF, did I say?
Yeah, you did. Yeah.
The work with EDF, there was at least a 6-month piece of work there, because they faffed around for ages. They got the EPC done, which was great.
Mm-hmm.
But then they said I had to go to my local network energy supplier at DNO, district network operator, who happens to be Western Power. They're really good. And I had to get permission to be able to strap an air source heat pump on the outside of the house. It's like, well, isn't that wouldn't you be doing that? Oh no, you have to get that done.
Right.
So I had to write off and get that back.
Yeah.
And then there was a few other things. So that process took a while before I then decided to go in a different direction, as I explained earlier.
Yeah.
So it could be done quicker, but you've still got to get, I would say, because it's a significant spend.
Yes.
You've got to get 3 or 4 quotes in, and as I explained as well, lots of them said that you've got to do it this way, and no, that's not a solution, because it didn't meet my wife's requirement, as I explained.
Yeah.
And for all of those who are married, no, sorry. Anyway, so I'll go there. But so yes, if you're under a pressure purchase because something's failed,
yes,
I don't think you can't just switch over like that. But you can be planning it,
sure,
over a 2 or 3 year period, saying, well, my boiler's now 10 years old. It's probably time to be replacing it.
Yeah.
And I'll be doing that in 2 years. Let's get the budget sorted.
Yeah.
But then you can start doing the quotes. It's a bit like looking for a new car, isn't it? And it's a big spend. You don't just go and buy it. Well, unless you're a lottery winner.
Mindset, it's being prepared, and I mean, just on the wider issue, I suppose I know Ryan's on the call as well from Dakin as it happens, but in terms of when it comes to pushing out more air source heat pumps to the general housing population, the new builds are clearly key, and there's a job of work which for people who are looking to convert oil boilers or gas boilers that need to go through the process that you've done very meticulously, but hopefully that process will simplify, because I mean, I've read around, I've heard other people, I mean, it does sound very, very complicated. I mean, just looking at some of these images and what's involved, it is quite unnerving when you think of the scale of some of the things that have to be done. But in some ways, like buying a car, you don't ask how your fridge works. I don't lift up a bonnet of a car. I don't really care how the car works. It just, so in some ways, the industry needs to simplify. They need to be responsible for simplifying it as well, because they need to make it easy for people.
So and you don't need. I'm a bit of a geeky techie.
Yeah,
I do like to know how things work. So you don't need to know how it works, but equally, you know, when you mentioned we've moved away from internal combustion engine cars, we have 2 electric vehicles.
yeah,
And I like to know how those work. And I you know, in buying that, I did a lot of research again, and it's just the way I happen to operate. But you don't have to do that level. But from a heating point of view, you're not buying it like a refrigerator or a cooker or something.
Sure.
You have to find a friendly heating engineer, and I can't emphasize the engineer enough, who can design it for you.
Sure.
That's the key.
Yeah,
it's not Joe Soap down the road who fits boilers for $1,000.
no,
Because they're over specifying them. They're not doing any heat calculations. They don't understand that the heating system as a whole, and I emphasize again the word system. They're just slapping on a thing that's completely over specified, that will cost a fortune to run.
Yeah,
They could, I think we had a 32 kilowatt oil boiler in our property before we moved over, and it used to, you know, do this. It was, you know, it would run for a bit and then it would cool down and then it would run again. We should have run it at a 50, 55 centigrade, and that might be something for everybody to do in their own home boilers. That's whatever method of heating you have. Try turning the hot water heating down so you're only heating to about 48 centigrade. And if you know, modern boiler would have 2 separate controls, one for heating and one for hot water, and turn the heating down, you know, a few degrees each time, during the cold weather, until it's too cold, and then just turn it back up slightly, and then it'll run a lot more efficiently, irrespective of whether you choose to go air source heat pump. One of the people I would recommend people watching is Heat Geek. And I'll put the link in the can send this PowerPoint. He talks about efficiency of systems, and that's I'll come and talk about the air source heat pump and what we've done with that. But it's about, you can do those sorts of things with your current systems and your current clients to drive down their costs now. And you can check to see whether your property will run well with an air source heat pump by turning that thermostat, not the thermostat, sorry, in the hallway, the heating in your boiler. Just keep clicking it down. Ideally, it should be able to heat your house at 50 centigrade. That therefore suggests that your boiler's, you know, 50% over specified. And it probably will be. So that's me preaching again. I'll shut up.
Darren he's gotten back to asking a question about your deal breaker and the servicing element. Did the supplier say what is involved in a service? Is the service regarding the heat pump only or the complete system?
So
heat pump only, what is involved in a heat pump service?
So I've only had one. So it has been, we had the system fitted in April 21 and I had the first service in April 22. He was a Dakin engineer from Dakin Central rather than the guy who fitted it. The support contract is with Dakin UK, and he came and did some pressure testing. He cleaned out the system. He checked the installation against their standards and was very pleased with the way it had been installed by my installer. It doesn't cover the hot water tank. That's something I didn't explain in my conversations. I don't know whether people have come across the Fully Charged show.
Yeah, Robert Llewellyn.
Yeah. He came across a product called a MESHWORK hot water tank, which is an intelligent hot water tank that sits on the internet. And I thought, oh, that's a good idea. Geek again. I contacted them and got a price, and it was about the same as a Daikin hot water tank. So I thought, well, I'd rather have that. So I then discussed with EcoBubble, and at the time they weren't installers and they hadn't been trained in MESHWORK tanks. But so mine was the first one that they fitted, and it ended up being the same price. I might have paid 100 quid more or something. But I'm been really pleased with that. Again, it manages the hot water depending on the demand that you have. I can see and I'll talk about how that's set up as well. So I think that's a much better product than a standard hot water tank, I would say, and it's a a couple of 100 quid more, and it will pay for itself and more because of it's not heating the hot water as much.
Yeah.
As a full hot water tank.
Mm-hmm.
I was just going to skip through some of these. This is this is fitment day. My air source heat pump. Can you see the screen here?
Well, we can see. I can see
this
the wires on a yes.
Yeah, so this is the technical bit and the bit outside.
Yeah.
So you've got the compressor and all the controls outside. Let's keep going, just because people might not even know what an air source heat pump looks like. So this is the fan behind the unit. You get, so mine's quite a large unit, and it's what's called a high temperature unit. It's a Daikin Altherma 3H HT. It's nominal 12 kilowatt system with an onboard heater of another 6 kilowatts, so it could go to 18 kilowatts. And then there's a separate 3 kilowatt heater as well inside. I'll explain. So inside my garage is then this unit that sits on the wall. The air source heat pump, the external unit, is just the other side of this wall.
Mm-hmm.
See, all these pipes are carefully insulated. This then flows over the top. You can see the pipes going over the back door, and then it goes to. This was the boiler cupboard in my utility room.
Mm-hmm.
The boilers gets taken out, and then this expansion vessel is put in place. It's not an expansion vessel. It's a 30-litre tank, and then the air source heat pump runs at whatever speed it wants to run at through these pipes here, through the route I said, and then I've got a separate pump that then pumps this around the rest of the radiator system. So it can be running at this speed, and the air source pump can be doing this, or vice versa. It's called hydraulic separation. That's part of the design of the system. Some people say that's less efficient. I felt it was the right solution for us, and that the heating engineers that I'd spoken to thought it was the right solution for us. Otherwise, then everything to the right of this picture is my heating system and wasn't touched.
Okay.
Check. I'm still married.
Yeah.
So this is the external unit. You can see again well insulated. Side view. Then that's the other side view of the what it is basically is you have a massive heat exchanger that's so air is sucked in by that fan and blown out the on the right hand side.
Mm-hmm.
Coolant flowing around that is then the first diagram I showed is then back to your chemistry from your O levels or your GCSEs. It's the compression expansion law of thermodynamics, and as the gas is compressed, it warms up, and then that is heat transferred into the water. So there's water flowing in these pipes here, and it's that process that generates heat via an air source heat pump. It's a reverse refrigerator. Okay, so it's taking so in the winter time, when it's -2, -3 outside or whatever, this will freeze up over time because they're there, and then the system goes into reverse and thaws that out. Otherwise, it can't operate. Right. So periodically, every hour or two, depending on the temperature and how wet the air is, it will go into reverse.
Okay.
So then this was my MESHWORK hot water tank. Again, I think it's a clever bit of kit. I'd highly recommend those. It's a 180-litre slim model, but they do them in various sizes from 150 up to 300 and something litres, and that's enough for we have a bathroom, two en suites, as well as hot water, other hot water needs, so that's sufficient.
Mhm.
And it has a very good recovery time because it heats from the top rather than heating from the bottom.
Okay.
It uses the incline, thermocline, sorry, and you're just heating the amount of hot water you need.
Yeah.
So this is where my oil tank was. So I used to have a huge 2,500 litre bunded, so that meant double skinned oil tank. So I've now got a big space there. I'm very proud of my shed, but you need a bit of space around the air source heat pump because it's sucking in the air from down here and then blowing out cold air. And if you get it just stuck in a well, it could, be sucking in cold air and then blowing out cold air, and eventually it would reach a point when it. But there is energy in the atmosphere down to again back to your chemistry, down to minus 273.15 degrees centigrade. Absolute zero is when there's no energy in the environment. So when we talk about, this will operate down to minus 20 centigrade. We never get minus 20 centigrade in England, in the UK, but it's sufficient even down to that. It seemed more than 1 to 1.
And now you've gone through 4 seasons. Has it performed to your expectations?
Sorry, I've got to show me a nice photograph there
with the rainbow.
And that's the final unit. I think this looks better than a lot of the units because it matches my black shed you just saw.
Yeah.
I've got black pipes, etc. You need to think about the design. Some of them just look like white refrigerators sat outside.
Mm-hmm.
It's just a personal thing. That's closer to again. Oh, you need to have somewhere for the water. When it goes into reverse, you have to think about runoff point. My good heating engineer put the pipe out the back. I said, no, I can do better than that. I wish I'd left it where I need to sort this out. That's the last of those photographs, but let me just give you a quick PowerPoint.
Yeah, just while we're waiting, I'll upload the chat as well to the MESHWORK, just because Simon's suggested a couple of things and Ryan's endorsed an eco bubble, etc. So it would be good to share that with everyone.
Can you see that?
Yes.
So this just talks about the efficiency. So the engineer, so EcoBubble did an assessment, and they said I was going to consume about 7,283 kilowatt hours of electric per year, and this is the per month demand, and then I've calculated the per day demand. So in the deep winter, I'm using about 55 kilowatt hours of electric predicted per day. These numbers, if you remember from my EPC, this was a design flow temperature at 65 centigrade with a predicted 3.64 SCOP. So that means 1 unit of energy in would have produced 3.6, so 364% efficient. So that's why air source heat pumps are the future, because a gas boiler won't get above 90%, and an oil boiler is at about similar 92% or something. So Simon, you asked the question about, so my predicted was this 7238, and my predicted SCOP. What I actually consumed was 4,239, again, and it generated a heat from the Dakin report of just over 16,000 kilowatt hours. So that means a SCOP of 3.78. So I'm 378% efficient.
Very good.
So that's only 58% of the predicted energy use. I broke even on my oil use. So it cost me about the same in electric, given the current stupid rates of electric compared to the stupid rates of oil and the current energy demand. So, and my CO2 emissions are well down.
Yes. Yeah.
I'm with Octopus Energy, which all their energy is green energy. So I would recommend everybody switch over to green energy supplier. That drives the market to switch off dirty oil boilers, gas and coal fired power stations.
And when you say,
So why,
when you say broken, this might be a silly question, but when you say broke even, you've broken even at a point, so your quid's in for the future, or is it every year you're looking to break even compared to what you would have paid if you'd remained with the oil boiler and
a good question. I don't think I've necessarily got an answer. As I'd like to try and continue to break even, but I think oil will only continue to increase,
Sure.
especially given the current situation. I think it'll end up being better. What my task is to do is to improve that 3.78 SCOP. I want to try and get it to 4. Let me just quickly skip on why I think there's differences. So I think the property is better insulated than the MCS calculation, based on all the conversations I mentioned earlier.
Yeah.
So I think that a heat demand, heat loss calculation was incorrect. I've got, that's a qualitative statement. I've got no quantitative other than these numbers. I think we operate at lower room temperatures than was predicted. So we're the hottest we put the house is at 28.5 centigrade, and that's only for late afternoon, early evening to 10:30, and then compared to the design, which was 22 centigrade in some of the rooms. I think I've lowered the flow temperature. It was running at 55 centigrade, and I will continue to compare to the specification of 65. Excuse me. We heat our hot water overnight. Some people leave it so it heats during the day, but the system, the air source heat pump, that's true with an oil boiler and a gas boiler, they can only choose one or the other. So it switches between the two. Well, there's an inefficiency as it switches over. So I think there's an efficiency gain there. And the question is, was 21, 22 a milder winter? I don't know. But 1 year is not a trend. My statistics head on. And obviously solar PV has heated my hot water, and heating hot water is quite inefficient with an air source heat pump. You're only on about 1 to 2. So it's about 200% efficient compared to heating the heat. So I think those are the reasons. So what might I do? Sort of future improvements. I controlled the system with a Nest, an intelligent thermostat that sits in the hallway, and it is an intelligent one compared to some of the other products on the market. It knows whether you have to tell it, but then it knows whether it's a gas boiler or an air source heat pump or an oil boiler. So it's now running on an air source heat pump. So therefore, it takes into account the heat times, etc. But I've run it for a year using the Nest controller, but I've now switched over to the Daikin weather compensation. Now we haven't got time to talk about weather compensation, but it uses a graph that's controlled within the Daikin, and all good air source heat pumps will do this. So if it's 10 centigrade outside, then it's only heating the water to 30 centigrade, say. If it's -5 outside, then it heats the water to 55 centigrade. And there's a straight line graph between those, and it will vary, and that will drive up the efficiency. It's all about letting the air source heat pump run longer, but at a lower temperature than your traditional gas or oil boiler, as I explained earlier, is spiking all the time. If you can make it run more efficiently for a longer period, but at a lower temperature, you'll save in your own gas and oil boilers or whatever heating source you currently have.
Okay.
So I shall continue to reduce the flow temperature on it until Mrs. Clark complains, and then we have to turn it back up again. As I said, my property was built in 2001. It has 50% filled with those. It's like a panel, isn't it? That the cavity is filled. Should I fill the other 50%? I ought to get some feedback from you guys about whether you think that's a good idea or not, from not from an insulation, but from a quality of life perspective, because you could potentially have more moisture in the house. But anyway, should I put? I have electric vehicles, but for me, the future of is to use something called vehicle to grid. And we could also have a separate conversation about vehicle to grid, but it's taking the charging the car up either free via the solar panels or on cheap cheap overnight electricity and then using that to run the house during the day, you can only do it with CHAdeMO. It's a specific connector. It needs to be developed. The solution needs to be developed for CCS or Type 2 connectors. That's a whole separate conversation. But it's my campaign. That's the next big thing. I don't want to invest 10 grand in a Tesla battery to sit in my garage when I've already got 100 kilowatt hours of batteries split between my 2 EVs. Let's use those to run my house, and that will then drive my costs down.
So you just answered, I mean, Ryan's just asked actually if you had a battery, but by the sounds of it, you don't.
No, I can't cost justify that, because as I say, I've got 2 electric vehicles, one with over 70 kilowatts and the other one's 30 kilowatts, so over 100 kilowatt hours of batteries. Why do I want to buy another battery when one of the cars is almost always parked in the garage? It's just not. So I have to. I do have an economic. And my wife was an accountant, as I mentioned. Do we put more solar panels on the property? Should we put in solar thermal? The early solar thermal systems were very inefficient. Not sorry, unreliable is a better word. And to get somebody who fitted it, you know, they were going out. They were going bankrupt left, right, and centre. Yeah. To get somebody back in to fix it, they wouldn't. But I'm sure that's changed today. And then I'm jokingly wear more jumpers.
That's what I tell the kids.
I can see I'm in an office at the moment. But for those of you sat at home, why have you not got jumpers on and turned the heating down?
No heating
on
on.
Cameras. But yeah, so that's my future change. I was lucky enough to get the RHI grant. It's now the best. No, I forgot what it's called. The new grant. But there's a new grant which is different. I would still have done it, but it made my costs a lot lower with RHI.
Right. Okay.
My system, it was 13,755, so 13,755. I got over 10,000 back through R8, or will get over RHI, and
so the new grant's only up to 5,000, isn't it?
Yeah. But it means that the cost that I end up paying is just the same as if I bought a new oil boiler. In place.
Yeah. Yes. But then with the new grant, the payback's going to be a lot longer compared to RHI.
Yeah, but the costs are coming down. You've got the likes of Octopus doing installs in a standard house. They don't do them for every houses. They've got the costs down considerably.
Yeah. Thank you. Yeah. Well, yeah, you've obviously researched it a hell of a lot and know your stuff, and could probably be employed by EcoBubble tomorrow.
You couldn't afford me.
Good answer. Does anyone else?
I have a lovely job in IT services, but I'm thinking about retiring in 2 years. Oh,
right. Okay. Yeah. Okay, so that's a nice little winter job there. Does anyone else have any questions? Tony, you mentioned about how you're looking to upgrade your system. Has Julian answered everything that you were looking to learn? No.
Up to a point. I'm some way behind in terms of the research, but I absolutely sympathise with the idea that you can't get comparative data. I'm also having real difficulty finding, as you say, an engineer. Find kind of lots of people who claim to be able to design things. Half of them are on commission, so they don't really trust them not to advise me to buy something inappropriate. And the other half aren't really what I would consider qualified. I'm an architect by origin, retired now. So I appreciate the idea of an engineer. That's really important, I think. I think that taken that away as well. The other thing that I had real difficulty with is the idea of the management and control system. You've mentioned some things in there, but that's something which is I've found really difficult to find out anything sensible about. I don't know whether you've got any comments on that.
I was going to share a final screen. So one of the disadvantages, I would say, of Dakin is it doesn't provide a great deal of information, which if you are a data geek, it's probably you can add a a module in, which is another couple of £100 that then provides, it puts stuff onto your local Wi-Fi, and you can download it onto your laptop. I decided not to do that. All I do is every week or so go out. There's a electric consumption meter associated with the air source heat pump, and I just go and read that, and I then take a reading off of the Daikin on its control panel. The reason being, when I first had my solar panels, every day I'd be going and measuring it was a Bluetooth connection, and I could get a download of the data, and after a month I just got bored. So companies like Mitsubishi EcoDan solution has a much better interface if you want to get that sort of data and want to integrate it with your home system. If this not then ITTT, if this not that, it'll integrate well with that sort of control system. I just decided against. I can't be bothered. I do enough techie and IT stuff and data through my job, and decided I didn't want to do it at home. And my wife and daughter certainly weren't interested. Yeah. But yeah, it was purely the long-term serviceability Daikin that differentiated it. I mean, even from a technical point of view, the technology of a Daikin compared to a Mitsubishi, compared to an LG, they're all very much the same underneath, I have to say. Even the Daikin marketing director said the same thing to me when I was at Fully Charged Live a few years ago.
Well, talking about Daikin, Ryan's going to be presenting next week on air source heat pumps within mixed use properties, retail below, flats above, etc. So there's another session on air source heat pumps next week. He's actually just asked. Yeah, go on.
Sorry, one I did want to make. People often say about, oh, they're too noisy, it's no good at all.
Yeah.
I think my air source heat pump is incredibly quiet. Even at full chat, you can't. There's a fence, you can't hear it the other side of the fence. It's quieter than when my oil boiler used to fire up through the flue, and that was running. So the air source heat pump is quieter than that. Noise is not an issue. No,
that's something. And then actually, we're hosting another session where it's a live event. I know Simon signed up to it, where there's and Ryan and his team are coming along, and we're literally going to kick the tires of a air source heat pump. And obviously, after Julian's images, we now know what an air source heat pump, but as you said, not many people do. So yeah, come along if you're in the Guildford area to that, because it will allow people to actually get deep down and dirty with one. And whilst we might not be able to set it up so it's running, there's we'll have a comparison from a noise level. So yeah, that's something else. I'm conscious of time. I'm conscious it's 1 o'clock now. It's been fantastic, informative, entertaining session. Thank you very much, Julian. Thank you for everyone's involvement as well. I will post this chat up as well. Ryan's just asked a question. He's obviously got his employer's hat on in terms of looking to know how they can improve, or how the industry can improve, making it easier for people to gather information. So any suggestions there would be welcome. But perhaps
I think you need a Top Gear of heat pumps. So
yeah,
you need a Jeremy Clarkson and a hamster and a.
We sort of have one of those in Graham Hendra, so yeah, we'll see.
Yeah, but it's a comparison between them, I think. And there's lots of YouTube channels. I'll send you the PowerPoint.
Yeah, and
I was just trying to share again.
Share it as well. I'll share it as well. But it's
no, not that one.
Yeah, if you email it to me, then I can upload it onto the link as well.
Can you see that?
Yeah.
So Heat Geek is certainly worth looking at. Renewableheatinghub.co.uk. They have a forum. I'm on there actually as Worcestershire Heat Pump, but they were the people I was interviewed by about a year, 4 or 5 months ago. I recommend Octopus Energy, an energy provider, because it's green energy and quite good value.
Yeah.
My Energy is my charger. my EV charger and a hub connected.
Yeah.
And then Earthwise Products are the people that make and supply the Solic 200, which is the energy diverter that I have. And if you have solar panels and a hot water tank for 200 quid, you know, why wouldn't it? It'll pay for itself within 18 months.
Yeah. I appreciate all the effort you've gone to here, Julian, in terms of sharing this and putting all the information together. It's been very, very useful. So yeah, much
You're most welcome.
Appreciated. And I think all the guys on the call have been saying how much they've enjoyed it as well. But people are starting to
happy wife, happy life.
Yeah, indeed. It's something I need to learn actually.
Please, if you've got further questions, you can ping me through the Mesh network. I'm more than happy. If people in rural Worcestershire travelling through, come and have a ping me, and we can meet up, and you can come and have a look and hear the thing running. As I say, it's more than happy to have further conversations.
No, thank you very much. Cool. All right then, guys. Well, thanks for joining, and yeah, we'll see you on the next call. Cheers then. Bye. I'm going to stop recording first.